Today we're going to talk about scientific notation. And basically, scientific notation is a standard way of writing either very large or very small numbers so that they're easier to compare, to manipulate, and just to using your calculations in general math. And so the general form for writing in scientific notation, you would follow this. N times 10 to the A. So here, N is a number between 1 and 10. It can be 1, but it cannot be 10. And A is an integer, positive, or negative. How this works is that you move the decimal point of a number until the new form is a number from 1 up to 10, and this will be your N. And then you record the exponent, which is A, as the number of places the decimal point was moved. Whether the power of 10 is positive or negative depends on whether you move the decimal to the right or to the left. Moving the decimal to the right makes the exponent negative, and likewise moving it to the left gives you a positive exponent. So here's another way to look at this. If your N is greater than 10, then your decimal has to move left, and therefore the power of 10, your A, will be positive. On the other hand, if your N is less than 1, then your decimal has to move to the right, and therefore the power of 10, your A, will be negative. So right now 800 is not in scientific notation, but if we want to turn it into scientific notation, here is how we would write it. 8 times 10 to the power of 2. Let's look at it this way. We can take 8 times 10 to the power of 2, which equals 100. 8 times 100. And this equals 100, bringing us back to our original point. So this is how this works. Okay, let's take a look at another example. So here we have 5,800,000,000. And so this number, if we did not condense it in some way, it would be a hassle to write it everywhere in our calculations. So how we would turn this into scientific notation, we would do 5.8 times 10 to the 9th. So here we can see that 5.8 is our N. And this works because N is supposed to be between 1 and 10, and 5.8 is. And our integer, our A, is 9. And in this case, it's positive because our number here is bigger than 10. It's huge. So we're going to multiply it by 10 to a positive integer. Now let's take a look at some examples that are smaller than 1. Previously, we did big numbers, but now we're going to do the opposite. So here is our first number, 0.0055. So in order to make this into scientific notation, we have to figure out what our N is. And so in this case, 5.5 works because it's in between 1 and 10. So now we have to try and find out what our integer A is. And so in this case, because our number is smaller than 1, we know that our integer will be a negative number. So now in order to find our A, we have to take a look at the decimal. Count how many spaces it takes in order to move the decimal from where it is right now to 5.5. And so you can see that we moved the decimal place 3 times. 3 times to the right, and therefore our exponent, our integer, our a value is negative. For our next example, let's use this really tiny number, 0.0000, let's do 68. So now that we're more familiar with finding our n value, we can just simply tell that our n is 6.8. So now we just need to decide what our a value is. But we know that it is negative because our number here is less than 1. So now let's count the decimal places. So in order to move the decimal from where it is right now to form 6.8, we need to move the decimal 5 places. So we know that our value is 5, and since our number here is less than 1, it's negative. So our thing in scientific notation is 6.8 times 10 to the negative 5. Now let's try something new. So instead of taking a number and forming it into scientific notation, we'll do the opposite. We'll take a number that is already in scientific notation and we'll undo it. Okay, since our a value is a negative number, we know that this number is supposed to be less than 1. And in order for 2.56 to become less than 1, we need to move the decimal to the left. So this indicates, the negative 6 indicates that we are going to move the decimal 6 places to the left in order to create a number that is smaller than 1. As final practice, here are 2 questions for you to do on your own. So pause this video and try to work them out yourselves. I will show the process if you need help. So, time to check our answers. The first thing I did was I found my n, 5.4. Now time to figure out my exponent, a. So I moved the decimal place to create 5.4, and I realized that I moved it 7 spaces. So the final answer is 5.4 times 10 to the negative 7. Now for the second question, this one's a little tricky because there are many other numbers besides 0. But still, we have to focus on what our n is. Our n is 3.1, and our a is 4 because we moved the decimal 4 places over.